Hey, this is Mr. Izad. I'm a teacher and a doctoral candidate for educational technology leadership. As you have happened upon my page, you may have noticed that I present on a variety of topics regarding use of technology in education. And today's topic is use of 3D printing and computer-aided design software to teach math concepts. Specifically, I will be demonstrating how using the SketchUp program to create a 3D model can aid students in their understanding of how principles of geometry can manifest themselves in real-world applications such as architectural design. After all, as per Common Core and New Jersey State learning standards, the ability to utilize technology to visualize different assumptions regarding math concepts and their implications in order to gain a deeper understanding of said concepts is integral to strategic and critical thinking, which should be encouraged in all subjects. The aforementioned learning standards also emphasize having students solve problems that would be encountered in real life, and there are many specific contexts in which certain concepts could be used to solve certain problems. And the activity that I have outlined in this video, which pertains to at least two learning strands, one of them having to do with the relationship between two-dimensional and three-dimensional shapes, and the other, geometric shapes and the associated formulas, has real-world implications in architectural design. Now, when dealing with shapes and their properties, it's always helpful to have a visual aid. This becomes a bit tricky when dealing with 3D shapes and the relationships among two and three-dimensional figures, as textbook images may have two-dimensional representations of them that may look something like this. For instance, if I wanted to determine the length of the right side of this pyramid, which is a three-dimensional shape, I would have to draw a two-dimensional right triangle inside it. That imaginary triangle is denoted by these dotted lines. As you can see, the two-dimensional image can get a bit cluttered. And whereas such a visual can be helpful, the process of determining the dimensions of three-dimensional shapes in terms of imaginary two-dimensional shapes within that three-dimensional shape still requires a bit of abstraction, and that can be a difficult process for learners. As such, additional scaffolds could be needed, and viewing the three-dimensional object in 3D can provide that scaffold. To invoke a study conducted in which 3D printing was used to teach students about concepts such as volume and cross-sections, examining these concepts using the 3D printer and CAD software, quote-unquote, provides depth and dimensions that they meaning students, would not otherwise gain from a textbook. Having said depth and dimensions, in the case of this study was integral to the profound understanding that students gained regarding the aforementioned concepts. So let us see how this notion of use of 3D printing and CAD software allowing for enhanced understanding can actually play out using SketchUp, shall we? As I mentioned before, the activity outlined in this video will have students solving a real-world problem which will involve application of knowledge of properties of two-dimensional and three-dimensional shapes. And as I also mentioned before, real-world applications of said concepts can be found within the context of architectural design. Using CAD software such as SketchUp allows for replication of such a context. For instance, say you task students with designing the model of a particular structure, say a pyramid, and the only parameter is that it has to be 400 feet high. There are a variety of ways to tackle this problem, as there are no parameters dictating how wide the pyramid has to be, or what shape the base of the pyramid should be. Given lists of relevant formulas or theorems, the teacher can model a solution for a problem, demonstrating how the formulas are applicable by drawing out the dimensions of the pyramid on the CAD software. Alternatively, students can work it out on their own using the CAD software as a visual aid to help them create the dimensions of their pyramid. For simplicity's sake, let us design a four-sided pyramid with a square base. Since the base has to accommodate for the height of the structure, let's make the base 500 square feet. Of course, since this is a model, we want to scale it down. So let's say every 2 inches represents 100 feet. In order to create the base, we are going to use the rectangle tool here. Since every 2 inches here will equal 100 feet, we want to make the rectangle 10 inches by 10 inches. which we can do by either dragging it out until it reaches those dimensions, or by inputting the dimensions in this bar right here. Since we're going for precision, let's manually input them. Now that we have our dimensions, we can use the orbit tool to get a bird's eye view of our square-shaped base. And we want to do this because we are making a four-sided pyramid, and as such, all sides of the pyramid will have to meet at the center, at least for the design that we are employing. Because we want all four sides to meet in the center, we would have to determine where the center is from each corner. We can do that by dividing the square into two separate isosceles triangles and determine the length of the unknown side, which is the imaginary line we are going to create. As we know that the length of the square is 10 inches, we can use the Pythagorean theorem to determine that the unknown side will be approximately 14.4 inches. Now we can test our calculations out by drawing the line. And we were right. Just note that even though the SketchUp software essentially does the math for you, you would be teaching the concepts within this context for visualization purposes, so students can clearly see how these concepts manifest themselves in the creation of a structure while using the software that individuals in the field of, say, civil engineering might be using. Plus, it provides students with a means of checking their own work. Moving on. The center of this line would be where all four sides of the pyramid would have to meet. So we would divide this line by 2 to get 7.07. And as the software indicates, our calculations are correct once more. Now because the pyramid has to be 400 feet high, and we are scaling it down so that every 2 inches equals 1 foot, we are going to draw a line up from the center that is 8 inches in height. And we will do this to determine how long each line will be from the corner to the center of the square where all four sides of the pyramid meet. We use the Pythagorean theorem for this once more, and we get 10.67. Now let's go back to the line tool and test our calculations. And we find that we are correct once more. And we see that is the same for all four corners. And now we have our completed design. So this is a very basic way in which the use of 3D printing and CAD software can be used to support instruction and application of math concepts in ways that meet Common Core and New Jersey State learning standards. And again, even though SketchUp does the math for you, teaching math within the context of architectural design can help learners see how math concepts manifest themselves in the creations of people, thereby allowing greater appreciation of those concepts and understanding as to why they have to be preserved. After all, it is important to have knowledge of these various math concepts, as it would be folly for humanity to rely on the technology to do the math for them. You know, lest Skynet go live or the dead begin to rise from their graves, which, in the case of both scenarios, leads to the ultimate collapse of civilization in which humanity would have to rely on knowledge of the past to create a sustainable future for themselves. Yep, in those instances, doing things the old-fashioned way could come in quite handy. Anyway, thanks for watching my video. Do check out the other videos on my page, and if you found this helpful or have requests as to other topics regarding educational technology that you would like to see presented on, let me know in the comments below.